overview of the mlops platform as it is currently. So mlops is an end-to-end tool for data science to move from your idea or your business project into production and business value as fast as possible. We do this by allowing quick iterations from the datasets to models to actual deployments. And we also encourage collaboration between people in the same team. So everything in mlops revolves around the project, and for each project you have one star KPI that helps you or your team to be aligned towards what actually matters for this project. So it's very simple to get going. You just type a project name and you set the metric that you want to use, and you do create project. So we're going to go into this one, and the first thing that we're going to be hit by is data sources. So a data source is any type of data that you currently have on your AWS account. It can be S3, it can be Dynamo, JDBC, RDS, whatever you fancy or have right now. And it's very easy for us to just add a new one. We can go here, we can choose S3, we can give it a name, Apple Mobility in this case. We add it, add, save data source, and save data source will create a crawler that will start keeping track of your data source from this moment on. Also looking at schema drifts, new partitions, etc. over time. And for each data source you can also review how the schema looks like. So once you have a data source up and running, or multiple, you can move on to datasets. And this is really where the iterative process begins. So datasets right now are created using PySpark. And to create a dataset, we do the same thing. We select the data source that we would like to use, App Mobility. We can generate a script template for us to get going. Currently we're working on allowing for local testing before submitting to your cloud environment, which will allow you to iterate on your scripts both for PySpark and for your machine learning code right in your browser. So once we've done this, we can go to next. We can select what type of job. Like I said, we do PySpark right now. Eventually we will support scikit and pandas as well for smaller datasets. You have to upload the script right now. Eventually you will be able to just save the one that you have edited in the browser. You select the worker, the number of workers, which basically gives you the CPU and memory of your job. You can also select how you want to split the data. So this would represent an 80% training set, 10% validation, and 10% testing. And since we also are very pro using a very iterative process to come up with the best combination of dataset and algorithm, we also support creating subsets. So in this case, I can create a 0.3, 0.5, 0.5, and a 1.0 subset. Now, what this would mean for us is that for each of these entries, I would create a single data set of 30%, 50%, and 100% of the data, which would allow us to both to decrease the computational effort and also to train the model faster. So, for example, if I'm in the beginning of a project, I might select to just go with 30% of the data if I have a big data set, before I have aligned the features with the algorithm that I want to use. So we press create, and create will start running a PySpark job. Once that is done, we can inspect the schema, both of the data and the labels and different splits. Right now we just have for this one a 100% subset, and we can look at test and validation. Obviously they all look the same. What you also can do is create or calculate the column metrics for each feature here, and then you will get the mean, STD, variance, number of null values, etc. etc. So once you have created a couple of data sets, you can move on and you create models out of that. Models is supported with XGBoost, TensorFlow, etc. Right now we have only TensorFlow, and basically it's the same process here. You select a data set, you move on, you select a framework, You select the type of instance that you want to run. So everything from smaller CPU instances to multi-GPU instances are available. The instance count, that would mean if you're running it distributed or not. The number of hyperparameters, you can add as many as you want. You can select hyperparameter tuning and then set an interval for each hyperparameter. Set the metrics to log, and as well the loss function. And once you've done that and uploaded your TensorFlow script, you can create a model. And for each metric that you selected during the model, you will also get a plot here. And after that, since we are multiple people working on this, and I can, for example, see that my colleague has hit a better RMSE than me, which is our star KPI for this project, I can go in, I can inspect his code, and I can start working from there. Once we have done that, we can move on and we can create a production environment, and that would mean going in live or going in batch, and then going with hosted or serverless hosting, the instance types, if this is a live instance or if you want to create a release candidate that gets just a part of the data from your inference points, how you want to sample the data, which means looking at response and request from the model, so you can look at that if you want to use acceleration and so on. So that's basically it right now, and we're very happy that we have launched, and we are really looking forward to accelerating the iterative process even more. And we're also working on collaborations with other super cool AI tools like supervised.ai for intensive production monitoring, as well as creating a marketplace for you to be able to sell your models and so on. So thanks for checking in. Bye.